So I've been having problems with this battery. The other couple of nights ago it just winked out, just wouldn't run the camper trailer. The guy at iTECHWORLD said charge it up, measure it the night before, so that was 13.96 I think it was last night, and he said then check it out in the morning, so it's 13.89. I had it on the charger, and when I tap it, like the current just bounces all over the place, so I thought we'd just do the same while we're looking at the voltage. I'll show you what it looks like on the charger shortly. So we've got it on charge. I've got it current limited to 2 amps. As you can see, that current bounces around a bit. If I give it a bit of a tap, that's not right. The terminals are all good. They're well terminated, you know, on the battery here. But as you can see, you know, give it a tap and it dances around a bit. So 1.3 amps at the moment. If I just let that sit for a bit, it'll just sort of jump around. I don't think that's how a battery is supposed to behave. It looks alright at the moment. It's doing a normal sort of a thing, but if I give it a tap, yeah, so, you know, like that's 1/4 of an amp now, 1/2 amp, 1 amp. No load, no current whatsoever, so it's like disconnected. So I'm tempted to pull it apart, but it's still in the warranty period, so what do? Do you go through the pain of taking it back? So yeah, there's definitely something that's disconnected inside. Okay, so I got too hard waiting for phone call returns for trying to do the warranty, so I thought I'd take things into my own hands, and I think I found the smoking gun. So it did a discharge test all right. It continued to power the this is what they look like. Continue to power a fridge for a while, and if we look at how loose this is, when I wiggled this, the charging kicked in and then it kicked out again. I reckon if I peel back that heat shrink here, we'll just see that the connection's a bit shit. And there it is, folks. I just started just cutting at this insulation here, and this just fell out. So that just hasn't been soldered in properly. We'll sort that out, and I reckon this battery will be as good as new. Okay, so I thought that was soldered in there. I pulled off the heat shrink, and it's just you can just see it just wasn't crimped properly. Oops, see that just sort of comes out of there. Maybe it was crimped, I don't know. So anyway, it's wiggled loose. So once again, we've got the bench power supply set to 2 amps current limit. So if we hook that up now to the battery terminal, see that goes to 2 amps, and it just stays there. It's nice and rock solid. We can tap the battery. Slip down here, do a bit of battery tapping. And that current stays rock solid, whereas before it was bouncing all over the place. So that was obviously the fault. It's very frustrating when you're speaking to these guys on the phone and they go, do an overnight test, and the problem with the warranty would be obviously, you know, if I take it there, they would guarantee that when they get it, it would just be in such a state that it would work flawlessly, and they wouldn't be able to pick any faults and all that running around trying to claim the warranty. So warranties, I don't know, they seem to be more painful than what they're worth. So let's have that flux burn off. I probably should be doing what I'm doing, but anyway. Just as long as you take some precautions and make sure you don't shorten stuff out. I think that's doing a better job. That might do it. So 13.35 and 13.43. So there's 0.1 of a volt drop while we're charging. So I had it wrong before. The meter on the left is the volts across the outer battery, on the outside of the charge circuit, and the one on the right is the actual voltage across the lithium terminals, I'm guessing. I saw a bigger change before, but that was because I was looking at the voltage at the charger, the power supply. Obviously there's loss in the cables, these little light cables that I got going charging. So they're kind of virtually the same. So that obviously they switch on some FETs, some big MOSFETs in there, and there's very little volt drop across there, dissipating very little power, so quite efficient, I guess. I'm curious to see what happens when we go past the charge, the maximum voltage, once it's charged, whether it lets go and disconnects. And same with when we do a discharge, at some point it must protect the battery and disconnect the output. So the wisdom on the street is that you should never charge a battery with a bench power supply, and for good reason too, unless you take certain precautions. I wasn't taking any of those precautions, so I decided to hook up a standard battery charger and see how that behaves. One of the dangers with using a bench power supply to charge a battery is you can feed power back into your power supply, damaging your power supply. What I do is I set the volts higher than I know what the terminal voltage of the battery is, and set some current limit, of course, and then connect it while it's all on. But I have damaged 2 power supplies doing just that, so yeah, not recommended. Check back. So yeah, warranties are good and all, but often these things break down when you're 100 k's or 1,000 kilometers away from place you can return them, and the hoops that you have to jump through to get your warranty. Like I said, if I took it to them to test it, no doubt on the day that wire would have just fallen into the right spot, and they would have tested it and they would have gone, there's nothing to see here, and there's definitely something wrong with it, obviously. That wire just fell out. So I think it was more interesting and quicker and less stress for me to just pull it apart, and then I get to learn something and fix the fault. I figured we'd come this far, I might as well open it right up and have a look inside. Nice big bus there, negative rail, positive rail. Obviously I'm guessing some MOSFETs there underneath. Part of the BMS. As you can see, the wires go off to the individual banks of cells, I'm suspecting. So we use polyamide tape to strap this module to the battery, but I can't help but think that that's kind of reducing the airflow over those fins, so I thought I might try and come up with something a bit different just to help the airflow. I think it's well and truly over-engineered, so it's not going to be a problem. But anyway, so yeah, that's what the battery's upside down. It was easier to pour everything out of the case than it is to try and pull it out. Okay, so that's the battery back in its box. I made some install changes. There was, I don't know if you can see those wires there for the cell monitoring. They were attached to that stake, and they were hard up against that sharp edge there on the BMS, that heatsink, and it looked like it was wearing through a little bit, so I've probably made a bad decision and rerouted it so there's it's well and truly away from that edge there. Also down there, this BMS, once that Kapton tape had cut through, it was free to flubber around. The other end had sheared through as it worn away, so this was free to flubber around. So I just put a little bit of foam there, a little bit of white foam there to keep it pressed in place. It's just very light, bit of just to keep it from bouncing around inside the case. I originally thought that bit of foam there sat up against these fins, but from the impressions like we can see on here, it was clear that it sat in this corner here. It definitely didn't sit up against those fins.